Hello everyone, welcome back. Today I'm going to explain a problem of flexural strength. An unsymmetrical I-section bridge girder has the following sectional properties: width and thickness of top flange 1200 mm and 360 mm, thickness of the web 240 mm, centroid of section is located at 580 mm from top. The girder is used over a span of 40 meter and the tendons are unbonded with cross section 7000 mm square, are parabolic with an eccentricity 1220 mm at the center of the span. Given FCK 45 Newton per mm square, FPE 1200 Newton per mm square, pre-stressed after all the losses. Estimate the ultimate flexural strength. Here in the question they have given as it is a I section, but it is a unsymmetrical I section. Top width of the flanges 1200 mm, thickness of the flanges 360 mm. Thickness of the web is 240 mm. The depth of the neutral axis, that is centroid of section, is located at 580 mm from the top. Length of the span is 40 meter. It's a unbounded tendon. Cross sectional area of the cable is 7000 mm square. Eccentricity is 1220 mm. By using these data, we should draw a diagram. You can see here it's a unsymmetrical section. Neutral axis is at a distance of 580 mm. Width of the flanges 1200 mm. Thickness 360. Thickness of the web is 240. Eccentricity is 1220 mm. Okay, like this, by using the data we can draw a diagram. Next is, in the solution we will write down all the datas, that is AP equal to 7000 mm square, FCK 45 Newton per mm square, FPE 1200 Newton per mm square. But when you see the effective depth here, first of all notation is small d. Directly they have not given small d value here, or overall depth also they have not given directly, but indirectly they have given the effective depth, that is depth of the neutral axis is 580 mm and eccentricity is measured from the center of the cable up to neutral axis. So 580 plus 1220 mm will give you the effective depth that I have calculated. It is nothing but 1800 mm. Next is, assume neutral axis lies within web. XU is greater than 360 mm. XU is nothing but it's a depth of neutral axis. It is more than 360 mm. This 360 is nothing but flange depth, or else you can use a notation like this. Yes, okay. XU is greater than DF, that is one thing. So for that, first of all, the standard formula we have for the calculation of the cable in the cable area in the flange, cable area in the web is AP equal to APF plus APW. In the question they have given the total area of the cable, that is AP value they have given. Using that we should calculate how much is APF and how much is APW, that is area of the cable in the flange, area of the cable in the web. So for APF we have a formula, that is 0.45 into FCK into BF minus BW into DF by FP. Substitute the values 0.45 into 45 into 1200 minus 240 into 360 by 1200. APF is 5832 mm square. This is the area of the area of the cable for the flange. Now, if we know the total area of the cable and area of the cable for the flange, by using these two, we can find out how much is the cable required for web. So, APW equal to AP minus APF is 7000 minus 5832 will give you 1168 mm square. First of all, why do we require these terms is, I will show you the ratio. That is, see here from table 12 for unbonded. Go to the or use IS 1343 page 59. There you will get table 12 for unbounded. In the question itself, they have given the tendons are unbonded, so we should refer to the table 12. See, like this, table 12 will be there. I have underlined it for unbonded tendons. If it is bonded tendons, you should refer to table 11, but it is unbonded tendons, you should refer to the table 12. So, here we have a ratio, that is AP into FP whole divided by B into D FCK. This to find out this ratio, we need a formula. We need all the terms values. But here I have made equal to APW into FPE by BW into D into FCK. So let me explain why did I write like this means. See, we have assumed that the neutral axis is lying in the web. When the neutral axis is lying in the web, then AP will become as APW and B will become as BW. Okay, if neutral axis is lying in the and FP will become FPE. If the neutral axis is lying in the web, then these are the changes. Not only if we assume also, we should consider the ratio like this itself. But if the neutral axis is lying in the flange, then no need to do any changes, just use the formula as it is. Okay, now we know all the values, so just substitute it. Don't forget BW is width of the web, will get 0.072 as a value. See, after this ratio calculation, we should find out how much is L by D ratio, that is effective span by effective depth. Effective span is 40 meter, convert that it into mm, so 40 into 10 power 3 by effective depth is 1800, will get L by D ratio as 22.22. By using these two values, okay, let me show you the table. See here, we should refer table 12. In this, what is the ratio value? It is 0.072. Just search if we have 0.072. 0.072 is not there, but that value will lie between these two values, that is 0.05 and 0.10. Between these two values, 0.072 will lie. The next thing is, we required XU by D ratio. Okay, the depth of the neutral axis value we required. So the thing is, because of this XU by D, after the first column we should refer these columns, that is these three columns are there, no, that is 5th, 6th, 7th. In between these three, where our value is lying, that column we should refer. Okay, so what is L by D ratio? It is 22.22. Where will that lie? 22.22. This horizontal values are L by D ratio. 30 is by L by D ratio. 20 is also by L by D ratio. 10 is also by L by D ratio. So 22.22 will lie between these two columns. That is, it lies between 5th column and the 6th column. I have understood that. But I should take the corresponding value of this. If as I said, 0.072 will lie between these two values, so I will consider this first value, that is 0.05. For 0.05, what is the value we should consider? It is 0.16 for 30 L by D ratio. Again, for 20 L by D ratio, we should consider 0.16. Next, for 0.10, value is 0.10, the value is 0.3, and here it is 0.32. Those values I have written here. The yellow colored one is a value which we should interpolate, and we should get these 30, 22.2, 20 and all. It is L by D ratio, and this first column is this ratio. Okay, like this we should interpolate. For 0.072, XU by D equal to 0.228 is a value. So I have written here, therefore XU by D equal to 0.008 from table, and D is known 1800, XU is 410.4 mm, which is greater than DF, which is greater than depth of the neutral axis, depth of the flange. So whatever assumption we have done, it is correct. Okay, so I have written a statement, hence neutral axis lies within web and assumption is correct. Okay, assumption made is a correct thing. And the next thing, why I have written this table is, the next thing what we require is, see, we have L by D ratio. Again, for this also, this for this second, third, fourth column, we require L by D ratio. That is ready. That is 22.22 is a L by D ratio. It is ready. By using that, we should find out what is FPU by FP ratio. So how we should read? Again, it is this column 0.005, the 22.22 lie between this 30 and 20. So I should refer this column as well as this third column also. So take the values from both the column. For 0.05, it is 1.21, 1.32. For 0.1, it is 1.18, 1.26. Okay, now I will show you the table. See here, it is written like this. L by D ratio is these horizontal values. This is the first column ratio. These are the values from the second and the third column. So we required for 0.072, how much is the value means it is 1.27. By interpolating, we got 1.27 has a value for FPU by FPE. We know how much is FPE, so multiply 1.27 into 1200. FPU is 1524 Newton per mm square. The next thing is moment of resistance. The moment of resistance formula is this one. This formula is applicable for the neutral axis lying in the web. If neutral axis is in the web, then we should consider this formula, that is mr or mu equal to fpw into apw into d minus 0.42 xu plus fp into apf into d minus df by 2. So substitute the values. It is 1524 into 1168 into 1800 minus 0.42 into 410.4 plus 1200 into 5832 into 1800 minus 360 by 2. Therefore, mu is 14.23 into 10 power 9 Newton mm. This is how the calculation is done for unbonded tendons by referring to the table 12. See, table 12, and the important thing is to remember is when we are finding this ratio FPU by FP, we should refer second, third, fourth column. When we are finding for or looking for XU by D ratio, we should refer fifth, sixth and the seventh column. But here in both the factors, L by D ratio is common. By using L by D ratio only, we will find out the values. Hope you have understood this problem. Thank you.